Myself S.Nithya, Assistant Professor, Department of Computer Technology, Vellalar College for Women. Let us see about data communications and networking. The OSI model, Understanding Network Communication. The Open Systems Interconnection Model is a layered framework for the design of network systems that allows for communication across all types of computer systems. It consists of 7 separate but related layers, each of which defines a segment of the process of moving information across a network. OSI model, a layered approach. The OSI model is built of 7 order layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Layer 1, physical layer. The physical layer coordinates the functions required to transmit a bit stream over a physical medium. It deals with the mechanical and electrical specifications of the interface and transmission medium. The physical layer is concerns with the following: physical characteristics of interfaces and media. The physical layer defines the characteristics of the interface between the devices and the transmission medium. Next one, representation of bits. The physical layer data consists of stream of bits, sequence of zeros and ones without any interpretation. Next one, data rate. The number of bits sent each second is also defined by the physical layer. Next, synchronization of bits. The sender and receiver must be synchronized at the bit level. Next one, line configuration. The physical layer is concerned with the connection of devices to the medium. Next one, physical topology. The physical topology defines how devices are connected to make a network. Next one, transmission mode. The physical layer is also defines the direction of transmission between two devices: simplex, half duplex, or full duplex. Next one, data link layer. Data link layer transforms the physical layer, a raw transmission facility, to a reliable link and is responsible for node to node delivery. It makes the physical layer appear error-free to the upper layer. Specific responsibilities of the data link layer. First one, framing. The data link layer divides the stream of bits received from the network layer into a manageable data units called frames. Next one, physical addressing. Frames are to be distributed to different systems on the network. The data link layer adds header to the frame to define the physical address of the sender and receiver of frame. Next one, error control. The data link layer adds reliability to the physical layer by adding mechanisms to detect and retransmit damaged or lost frames. Next, flow control. If the rate at which the data are observed by the receiver is less than the rate produced in the sender, the data link layer imposes a flow control mechanism to prevent overwhelming the receiver. Next one, access control. When two or more devices are connected to the same link, the data link layer protocols are necessary to determine which device has control over the link at any given time. Next one, network layer. The network layer responsible for the source to destination delivery of a packet, possibly across multiple networks, whereas the data link layer oversees the delivery of the packets between two systems on the same network. The network layer ensures that each packet gets from its point of origin to its final destination. Specific responsibilities of the network layer includes the following: routing. When independent networks or links are connected together to create an internetwork or a large network, the connection devices route the packets to their final destination. One of the functions of the network layer is to provide this mechanism. Next one, logical addressing. The physical addressing is implemented by the data link layer, handles the addressing problem locally. If a packet passes the network boundary, we need another addressing system to help distinguish the source and destination systems. The network layer adds a header to the packet coming from the upper layer that, among other things, includes the logical addresses of the sender and receiver. Next one, transport layer. Transport layer is responsible for source to destination end-to-end delivery of the entire message, whereas the network layer oversees the end-to-end delivery of individual packets. The transport layer ensures that the whole message arrives intact and in order, overseeing both error control and flow control at the source to destination level. For added security, the transport layer may create a connection between the two endpoints. Specific responsibilities of the transport layer include the following: service point addressing. Computers often run several programs at the same time. For this reason, source destination delivery means delivery not only from one computer to the next, but also from a specific process on one computer to a specific process on the other. The transport layer header therefore must include the type of address called a service point address. The network layer gets each packet to the correct computer. The transport layer gets the entire message to the correct process on that computer. Next, segmentation and reassembly. A message is divided into transmittable segments, each segment containing a sequence number. These numbers enables the transport layer to reassemble the message correctly upon arriving at the destination and to identify and replace packets that were lost in the transmission. Connection control. The transport layer can be either connectionless or connection oriented. A connectionless transport layer treats each segment as an independent packet and delivers it to the transport layer at the destination machine. A connection-oriented transport layer makes a connection with the transport layer at the destination machine before delivering the packet. After all the data are transferred, the connection is terminated. Next one, flow control. Like the data link layer, transport layer is responsible for flow control. Next one, error control. Like the data link layer, the transport layer is responsible for error control. Next one, session layer. Session layer. The session layer is the network dialog controller. It establishes, maintains, and synchronizes the interaction between communicating systems. Specific responsibilities of the session layer are dialog control. The session layer allows two systems to enter into a dialogue. It allows the communication between two processes to take place either in half duplex or full duplex. Next one, synchronization. The session layer allows a process to add checkpoints into a stream of data. For example, if a system is sending a file of 2000 pages, it is advisable to insert checkpoints after every 100 pages to ensure that each 100 page unit is received and acknowledged independently. In this case, if a crash happens during the transmission of pages 523, the retransmission begins at page number 501. Pages 1 to 500 need not be retransmitted. Next one, presentation layer. The presentation layer is concerned with the syntax and semantics of the information exchanged between two systems. Specific responsibilities of the presentation layers are translation. The process in two systems are usually exchanging information in the form of character strings, numbers, and so on. The information should be changed to bit streams before being transmitted because different computers use different encoding systems. The presentation layer is responsible for interoperability between these different encoding methods. The presentation layer at the center changes the information from its center dependent format into a common format. The presentation layer at the receiving machine changes the common format into its receiver dependent format. Next one, encryption. To carry sensitive information, a system must be able to assure privacy. Encryption means that the sender transforms the original information to another form and sends the resulting message out over the network. Decryption reverses the original process to transform the message back to its original form. Next one, compression. Data compression reduces the number of bits to be transmitted. Next one, application layer. The application layer enables the user, whether human or software, to access the network. It provides user interfaces and support for services such as electronic mail, remote file access and transfer, shared database management, and other type of distributed information services. Specific services provided by the application layers are network virtual terminal. A network virtual terminal is a software version of a physical terminal and allows user to log on to a network host. Next one, file transfer, access and management. This application allows a user to access files in a remote computer, to retrieve files from a remote computer, and to manage or control files in a remote computer. Next one, mail services. This application provides the basis for email forwarding and storage. Next, directory services. This application provides the distributed database sources and access for global information about various objects and services. Thank you.